Welcome, everyone. It's great to have you all here. We've got two great talks lined up here. We're going to begin with Kyle Allaire from Worcester State University about transitioning a modeling first approach in differential equations from a more traditional approach. So you can take it away, Kyle.
Great, thanks. So it's good to see you. I remember you from the Mind workshop, so
yeah,
good to see you again. Thanks for hosting and thanks for giving me the opportunity to talk today. So yeah, as Tova said, I'm going to talk a little bit about my experiences going from a more traditional style differential equations class to a more modeling first approach, and especially with a focus on me being an early career faculty member. So a brief outline of what I'm going to talk about. So I'll introduce Worcester State University, the type of students that we have, my position there. I'll get into why I'm trying to transition to a more modeling first approach. Then we'll get into two different topics really. At Worcester State, we offer not only a differential equations course, but also a math modeling course. So I'll talk about kind of differences between those and trying to develop each of those courses. Fourth, I'll get into some of the feedback I got from students actually in my math modeling course about more of a modeling first approach. And then lastly, if there's other like early career faculty members here, I'll go through some of the modeling activities that I use, as well as some of the resources that Semiod has to offer. So a little bit of a PSA about Simeo. Okay, so yeah, Worcester State is where I work. That's in Worcester, Massachusetts. So it's a state university. It's fairly teaching heavy in terms of the focus of the department and the university. So we carry a 4-4 teaching load usually. Definitely have some research requirements, but for sure it's a teaching focused institution. So that's kind of the background of my school. And in terms of what I was talking about a little bit earlier, not only do we offer an ordinary differential equations course, but we also offer a math modeling course, okay? We don't have any engineers. There's no engineering school at Worcester State. So the student body that are usually taking differential equations or even this math modeling course, they're usually math majors, and a good percentage of them are going to go on to be either high school teachers, middle school teachers, but there's not really a whole lot of interdepartmental play with these classes. It's mostly just the math majors that will be taking these sorts of classes. Okay, so that's the background in terms of my school and what we kind of have to offer in terms for our students. Just a background of how I got into teaching differential equations in the traditional sort of sense, and why I'm going into this more of a modeling first approach. So I taught ODE for the first time in my second semester at Worcester State in spring 21. This was a remote semester, so I taught through live Zoom lectures, but it was a traditional class, so it was synchronous. We met during the regular meeting times, and I had my tablet, would teach with my tablet as basically our whiteboard. So it was like a regular class, but just in a remote setting. But I taught that first semester, as you would imagine, it being my first year. I kind of went off what I knew. So I used my colleagues, which is always a great resource as a first year faculty member. And actually, I'll also use some of my notes from my undergraduate days. And teaching in this sort of traditional sense, right? I didn't know anything about this kind of modeling first approach. It's a very cookbook sort of technique driven class. And it was comfortable for me because that's what I was used to, but it was also comfortable for my students. I think they liked learning in this sort of way. That's what they were used to. So when I got the student feedback towards the end of the semester, it was pretty good overall. So in teaching in this traditional sort of sense was pretty good. And as an early career faculty member, pretty worried about student evaluations. We have reappointment binders that we have to put together every year with our student evaluations, among all the other things that go into tenure. But it kind of worked, right? So this lecture sort of technique-driven style of a class was comfortable for me and my students, and it worked. So why change, right? Well, when I dove into the student evaluations a little bit more, there's a question that kind of focuses on student interest and their motivation within the material. So when I looked at that, it was very, very, low and average at best. And that kind of caught my eye. And the reason being because differential equations are a fun topic, right? They can be very dynamic, they can be very fun, they can be very hands-on. So why are we presenting differential equations in this kind of cookbook, sort of, if it looks like this, we use this technique, right? Why are we presenting it as sort of this technique driven and sort of a boring way, to be honest? And in addition to that, after looking through my student evaluations, I had heard from a colleague about Simeo. And I want to focus on the mission statement from Simeo. This is right from the Semiod website. And I won't read the whole thing, but the thing I want to focus on are those bold words there. So modeling engages and motivates students, right? It makes them curious. And I think that was lacking in the way that I was teaching differential equations in that sort of traditional sort of manner, right? Like it was very cookbook. If you have an equation, it looks like this, we use this technique, blah, 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 right? And that motivation for kind of learning why these differential equations are important and how they can be used was lost in a way. Okay, so that was kind of why I got into this sort of modeling first approach. And beyond the fact of kind of using a modeling first approach as like the focus of the class, to me, that mission statement and modeling first really means not just focusing on modeling, but also the kind of the order in which you present things. So I also mean modeling before techniques. And I think this kind of like small little detail makes a big time difference in terms of the motivation for the students, right? So like before in a traditional sort of class, I would, cover topics on techniques for solving differential equations. And then once we learn the techniques, then I would go into the modeling afterwards. And, by the time we got to the modeling, I think the students were just like, okay, we learned this technique. All right, now let's use it in this sort of situation. I think switching the order of those things to use the modeling first, to come up with a question, give students a reason for learning. If you are going to cover those certain techniques, give them a reason to learn those techniques by providing the motivation with a mathematical model. Okay, so that's all I'm saying there. Use modeling to I wanted to introduce more of a modeling approach in that differential equations class, but that won't come up until spring 23. So ODEs is only offered every other year at Worcester State. Can everybody hear me all right? It says my internet's kind of.
It cut out for a minute. So we missed the last bullet point of the previous slide, but
the last bullet point, Tova?
Yes.
Okay, yeah.
And we're losing you again. Okay, I think you're back.
Sorry about that. Is it better now? Yeah, okay. All right. So, yeah, so as I was saying, I don't know if you had heard this, but we only offer differential equations every other year. I won't be able to implement these modeling first approaches until hopefully it's my turn to teach it again in spring 23, but I'm not sure if it will be. But I do get a chance to practice implementing these modeling activities and implementing this sort of modeling first approach into, like I said, we offer a math modeling course at Worcester State. And this is every year. I'm teaching it now, but I also taught it in fall 21. And the math modeling course at Worcester State, we kind of have a little bit of a free reign over what we want to cover. But we do cover things a little bit more broadly than just differential equations. So we look at in other words, difference equation models at the beginning of the semester. Then we get into the differential equation stuff, but we also cover some statistical modeling as well. So it's a little bit more broad. So we can't get into the nitty-gritty details of a lot of the differential equation theory and things like that, and all of the techniques in differential equations. But we do cover probably a third to a half is a differential equation. Okay, so things like separable equations, those are really the only technical sort of types of equations that we get into numerical. First, and then afterwards, once we had that motivation to kind of figure out the solution to a differential equation, right, or figure out what the stability first, and then look at the mathematical analysis and the technical stuff afterwards. Okay, so Tim Antonelli, I don't know if he's here, but he has done Semiod with me before. He works at Worcester State with me, and he gave me all of his materials for this mathematical modeling course, right? And when I wanted to implement, after learning about all the different modeling activities that Semiod had to offer, when I wanted to implement those modeling activities into my class, I started small. I just took some things that could be used in one given class period. So when I taught this class in the fall, I used all kind of one-day activities, and the students liked that. They liked having hands-on modeling activities in class that they could engage with, right? Back to that engagement that I talked about with the Simeo mission statement. They like this. They like being able to engage with some modeling activities in class, create models based off of some assumptions. But when I got the student feedback at the end of the semester in the fall, students wanted a little bit more. They wish they could have kind of tackled some larger real world problems besides those kind of like small one-day activities that we did in class. So this semester, larger projects. So at the end of the semester, I'm going to have students present on a larger modeling topic, and they're going to have to write up a report as well. So we'll see how that goes. But I think listening to student feedback, to talk, or I wanted to get a feel from my students about what they felt in terms of whether or not this idea of kind of introducing the modeling first and then studying the techniques and then looking at the stability and analyzing the differential equations, did that motivation come from bringing up the modeling first and then going to the analyzing after? Okay, so at the end of the fall, sorry, go ahead.
Sorry, we've been losing you again. Math department had a suggestion that you could turn off your video, and that
Okay.
then would all go to vocals so that we don't keep losing.
Sure.
So that would be an idea to try, maybe.
Sorry, I'll give it a shot, Toby. Yeah. Hold
Okay.
on. Thanks. Sorry about this.
No problem.
Well, all right. So hopefully this is a little bit better. So yeah, as I was saying, I'm not sure how much you had heard, but I wanted to get a feel from my students at the end of the fall, whether the introduction of the modeling first and then studying the techniques after provided that motivation to learning the more technical aspects of differential or even difference equations. And I asked my students to either agree or not agree with the statement. The in-class modeling activities provided that motivation in order to learn the more technical aspects. And almost to a T, students agreed with this, that the introduction of the modeling first provided the motivation to learn the more technical aspects after. And one student, in fact, at the end of the semester, when they were asked to provide some open feedback, they told me that the modeling activities were great to see how these equations related to real life. Okay, so I really think that the order in which either you do the modeling first and then go to the technical aspects after, I really think focusing on that modeling first provides that motivation for the students to kind of tie the equations into real life and give them motivation to analyze them. Okay, so that's the math modeling course, and as I mentioned, ODE is offered every other year. So I won't have time to, or I will have a lot of time to implement all these modeling activities into that particular course, since that's a spring 23 course. And the way I want to do it is similar to what I'm doing in my mathematical modeling course. I want to implement smaller modeling activities before we study, say, separable equations, in order to provide motivation for the students to actually be excited about solving differential equations, more technical aspects of it. Okay, some examples that I have used in my math modeling class, and many have been adopted from Semiod. First day, I bring in a potato into class. I did this in my mathematical modeling class, and before we even talk about things like equilibria or stability or the definition of what a differential equation even is, on that first day, I want them to get a feel of some real world scenarios that we may want to measure, we may want to model, right? So I bring in a potato and I have the students predict what they think will happen, right? Can they draw out a predictive graph about what the temperature of the potato will be over time, right? How should it look? And I don't want to get into all the nitty-gritty details of differential equations or even difference equations on that first day, but I just want the students to get a feel for what is to come, right? We don't discuss that the equilibrium solution is the room temperature, but we do talk about, like, what does that kind of mean, right? It looks like the potato is flattening out towards room temperature over time. They predicted that. And then once we get into the definitions of what equilibria are and what stability is, students are more apt to kind of make those connections to the things that they have seen in the real world. Another activity that I use to introduce separation of variables, I did a kind of fun example with a murder mystery. So I involved some of my colleagues in this. So it's a little bit of a fun activity for the students, right? I pose a problem. I pose this problem of a murder mystery, and we got to figure out how to solve this murder mystery. Okay, find out who the prime suspect is. And once you draw the students in, with this activity, they're more apt to want to be able to figure out how to solve the equations that are involved. Another example that I got from Semiod is a boarding school flu pandemic, so that can be used with logistic growth to introduce kind of logistic growth, or the SIR model. And you can do things like bring M&Ms to class. If you look on the Semiod website, it's a fun little activity that students can use M&Ms to represent the three different groups in the SIR model. So there's so many resources over at Semiod. If you go to their website, there's so many ready-to-use resources, especially as an early career faculty member. These were absolutely amazing to be able to use and just implement them into class. Okay. Sure, time getting a little close. Okay. So I won't go to that website, but there's a ton of downloadable tech files. You can edit them to, so you can go on the Simeo website and check those out. And then one last thing I want to talk about in terms of other Simeo resources. Tova also was at the Mind workshop over the summer. It's an NSF funded 1-week summer workshop. So highly suggest this as an early career faculty member. It's an NSF funded 1-week summer workshop in which you can learn about all the different Semiod resources. And more than that, you get to observe some expert faculty members demoing modeling activities that they have used in class. So people like Brian Winkle, who is great. He has done some demos at these Mind workshops that I have used and taken them into my own classroom. So it's really a great resource. I'm not sure exactly when it's happening this upcoming summer, but last summer it was in early June. So I highly suggest applying for that, especially if you're an early career faculty member. And then the nice part is at the end of the week at this Mind workshop, each and every one of us got the chance to present our own modeling demo. And the one that I presented with my group, I use that in my own classes this past semester as well as previous semester. So it's super useful. And I really can't say enough about Semiod and that Mind workshop that I was able to attend. Okay, so I think I'm getting a little short on time. So sorry that you weren't able to hear all of the talk, but thanks to Tova and everyone for giving me the opportunity to talk.
Thank you very much, Kyle.
Thanks. So sorry about that.
That's okay. Turning off the video totally fixed the audio. So taught everything from there on. And yeah.
Okay, perfect.
Yeah. What questions do people have? You can feel free to unmute yourself and ask, or to type in the chat and I can read them.
Oh, I think you're muted.
Mute. Kyle, my name's Kyle. I'm in a school that's similar to yours.
Yeah.
It's a little smaller. And I'm at the other end of my career. This is my last year. So this is a question about if, in addition to teaching math majors and teaching majors, are my departments pushing a little bit more in the engineering direction for students who transfer away from our school? And I've already ditched series solutions and Laplace transforms, which are so much fun, in order to do more projects. And it may not be something you know, but maybe somebody else in the group knows. I think there's one actual engineer here. How important are those things, those methods of Laplace transforms and series, as opposed to doing modeling, which is so fun too?
Yeah, we don't have an engineering school, and it's like you were saying, it's more like the teacher focused stuff. So I'm not sure I'd be the best at answering that question. I'm not sure.
Heather might have her hand up there.
Okay, go ahead.
Yeah, it's now. Let me get my mic, because I'd like to speak to that for sure.
Can you guys hear me?
Yes.
Okay, great. All right. So I didn't expect to be talking, so I haven't set up. I do want to talk about that because I teach in a small liberal arts school that does have an engineering program. And so we have a small program, but I teach the system dynamics classes. And we use the Laplace method almost exclusively to solve our problems. So in engineering, electrical and mechanical engineering, Laplace method is probably one of the primary methods of solving differential equations. And then also series expansions we use all the time as well. So both of those topics I would say are really critical for engineering students.
Yeah, I was in engineering school for a while as a student in electrical engineering, and we use Laplace transform all the time. And when you would look at a circuit, you would sort of immediately sort of transform the whole circuit into the frequency domain. And you get to the point where you kind of think that way, where you sort of think in that domain rather than necessarily in the time domain. Although when I teach differential equations, I do teach the Laplace transform, but really just so that and most of my students are engineering students, just so that they can sort of see it, so that when they actually go into engineering school, it won't be coming as a shock to them. But if they do go into engineering school, they'll be taking a lot of Laplace transform classes that are just doing Laplace transforms day after day after day. So you don't necessarily have to teach too much about it, I think, because they will get exposed to it until they're sick of it, basically, in engineering school.
Yeah, I would agree, but it is so helpful, you know, on like the second day of class when I say, okay, you guys all took ODE. Do you remember Laplace transforms? You know, at least if they can like kind of shake their head and say, oh yeah, I remember the name, you know, then there's less of this pushback, like, why are you expecting us to know something that we never learned?
Yeah, thank you.
Cool. Awesome question and feedback. That's great. I'll let Chris start setting up slides, and conversation could continue. We have like 2.5 minutes here until the next talk begins. So go ahead and start setting up your slides, Chris.
Yeah, I'll throw something out real quick. One of the issues I always have, I teach differential equations every semester, and I'm at a community college, and they kind of let me do whatever I want, which is kind of nice. And there's always the issue of what I should teach, because there's no way to teach everything in just one semester. It really should be like a 3 or 4 semester course, in my opinion. It's so important. And no matter what you teach, you're always going to leave something out that's really important. That's my feeling. You just can't cover everything. All right, let me set up my slides.
Yeah. Kyle, there was also a question in the chat. If you could either answer while Chris is setting up his slides or type it into the chat. Could you explain a little more about the murder mystery activity? That sounds really intriguing.
Yeah, sure. So I actually did this on my my job interview talk. So I had made like a modeling scenario where, you know, the president at Worcester State was found, you know, murdered in their office, and a few of the suspects were my soon-to-be colleagues. So I don't know if you met Tim Tova at the yeah, so he was one of them. But yeah, so I made, you know, I set up like the times that my colleagues had met with the president, and he kind of had to backtrack and use Newton's law of cooling to figure out, you know, at what time the murder took place. So it was just like a fun little thing that the students have fun because they know that my colleagues and think it's pretty funny. So.